All right, so we got one more example here, and it involves that same region that we had before, right? So we're referring back to that region we had in example 4 where it's the region between y equals x and y equals x squared. So let me draw what that looks like. All right, so there's the region that we had before, and in this problem we're going to rotate it around the line x equals -1. All right, so here's -1, and then here's -2 and -3. So we're going to rotate it around this line. So this is -1. So this is x equals -1. We're going to rotate it around that line. We just go like that, just to indicate we're going to rotate it around there, okay, which is going to create a mirror image over here. All right, so let me draw what that mirror image looks like. So we're going to have the line y equals x, and then the curve like that. Now that's not the equation of this line. This is just the mirror image of the of what we have on this side. So, all right, this is always trying to draw what this looks like is kind of a pain. So, all right, so, well, yeah, I know. That's not a real good looking diagram, but hopefully you get the idea. So what I've done is tried to draw it so it looks like it's in 3 dimensions. I rotated it around so you get this almost bowl-shaped thing, only it's really open in the bottom, right? Because there's this hole in the middle. And I've tried to draw what one of the washers looks like. So this red thing that I've drawn here is one washer, what that is supposed to look like. Okay, so we need an inner radius and an outer radius. So let's just write down what those are. Outer radius. Now, so we're going from y equals -1, right? So our outer radius is essentially just going to be 1 plus the distance over to the curve y equals x squared. Okay, and now y equals x squared, now I'm going in the x direction, so I really want x. So x is equal to the square root of y is just another way to write that same thing. So that'll give me the amount over in the x direction. Okay, so I'm going from -1 over to the y-axis and then an additional amount over to the curve y equals x squared, which is the same as x equals square root of y. All right, so we're going to end up with 1 plus the square root of y. Okay, that'll be the outer radius. Now the inner radius, we can kind of get in the same way, right? We're going to go over by 1 to get to the y-axis, and then we have to go over to the line y equals x. So we're going to, so the inner radius is essentially going to be 1 plus y. Okay. Or 1 plus x, or 1 plus y, it's going to be the same thing. But I want everything in terms of y because my thickness is dy, so I want to integrate with respect to y. All right, so let's do this integral. We're going to integrate from 0 to 1, and we're integrating in the y direction. So we're going from y equals 0 to y equals 1. And then we're going to take these two these circles essentially. They're going to take the area of a circle the area of the outside circle minus the area of the inside circle will give us the area of the washer that we're integrating. So we're going to get pi, and the outer radius squared is going to be 1 plus the square root of y squared minus pi times the inner radius squared, 1 plus y squared, and then dy. Okay. All right, so now we just need to go through trying to solve this. All right, so I'm going to start just by pulling out the pi, and I'm going to integrate from 0 to 1. I'm going to expand these squares, so it'll be easier that way. So I'm going to 1 plus 2 square root y, and then the square root of y squared is going to be y. Okay, and then minus this 1 plus y squared gives me 1 plus 2y, and then plus y squared. And then all of that times dy. Okay, can't forget the dy. All right, now let's clean this up a little bit. So we have pi integral. All right, so we have 1 here and a minus 1 here. So those are just going to cancel out. And then let's see what else. I get there's only one y squared term. I usually like to write my my polynomials in descending power order. So we're going to get minus y squared. And then we've got 2 y terms, right? We're going to have y minus 2y. So we're going to end up with minus y. And then the only thing we have left is this 2, so plus 2 square root y. Okay? So if I clean that up, that's what we get. So dy. All right, whoops, integral from 0 to 1. I'm going to forget my limits of integration. And then we just need to do the integral, right? So we have, let's see, I'm just going to leave this pi out front, and we're going to get minus 1/3 y cubed minus 1/2 y squared plus 2, and then I'm going to integrate the square root of y, so we're going to end up with times 2/3 y to the 3/2 evaluated from 0 to 1. All right, now obviously the 0 is not going to matter, so I'm just going to evaluate everything at 1, and then I'll have my answer, right? So pi, and I'm going to get minus 1/3 minus 1/2, and then plus, looks like 4/3, and then times 1. All right, so this is, let's see, minus 2/6, this is minus 3/6, and this would be plus 8/6. So it looks like we get 3/6, which is 1/2. So it's going to be 1/2 pi, or we could write it as pi over 2. And that's it. So, like I said, so the next thing is just discussion questions. Sometimes the trickiest thing is just drawing these darn pictures to get a visual. At least I feel like I need a visual to figure it out. So go ahead and take a look at the discussion questions, and I'll see you in class.